And this is video 3, switch operation and configuration. And there's a lot of different categories of information that are contained in this particular lecture. As you can see right off the bat, we're going to spend a few minutes talking about Ethernet. In just a few minutes, it's going to be a general review of some speeds and some things to watch out for. Also, for those of you who have not had the opportunity to work with gigabit Ethernet or 10 gigabit Ethernet, whoever thought there would be such a thing, this will be a good introductory lesson for you. We're going to talk about that for a few minutes and then talk about how a switch builds its MAC address table. And that's information you may recall from your CCNA. It'll be a good quick review. We'll see some of this in action. We're going to talk about some basic switch commands as far as configuring a host name, which you should know how to do as a CCNP candidate, putting an IP address on VLAN 1 and why we would do that, and the different switch passwords. So the first part of this may be just a review for you, but it never hurts to review this material, and you are responsible for it on your upcoming switching exam. Then we're going to talk about some helpful admin commands, just some commands here and there that'll help you with your switch administration. And then after that, we're going to go into a very detailed look at ether channels. Now, if you have no background with ether channels or you're not quite sure what they are, don't worry about that because we're going to start with the basics. Because some CCNA curriculums have ether channels and some don't. If you studied with my materials, you know how to build an ether channel. We're going to the next level with our ether channel knowledge. We're going to talk about the protocols that actually assemble an ether channel, so to speak. I'm going to give you some real-world examples of things to watch out for when you're configuring one and after you finish configuring one. It's going to be a good lecture. So let's get started then with just a quick overview of Ethernet. And of course, Ethernet is based on your IEEE 802.3 standards, offers a bandwidth of 10 megabits per second, and runs at half duplex, which means that a host running Ethernet can only send or transmit at any given time. It cannot do so simultaneously. And I know you are familiar from your intro studies and your CCNA studies about CSMA-CD, which is the collision detection mechanism in Ethernet. If you're not familiar with that, you might want to go out and do a quick check on the net for CSMA-CD and just review that. Wouldn't be a bad idea. You're not going to see it on your advanced switching exam, but if you're rusty with that topic, you should take a look at it. And when we're talking about collision domains, our switch ports serve as a collision domain with one host as long as each host is connected directly to the switch. So one of the reasons we use switches is to avoid collisions. And if all of our host devices are connected to their own switch port, we literally cannot have any collisions. They are all in their own little collision domains. Ethernet uses UTP cabling, unshielded twisted pair. The cable limit, good thing to know, is 100 meters. And we're going to map this a bit to our Cisco 3-layer model that we keep coming back to, where we've got our core, then our distribution layer is outside of that, and then our access layer is outside of that. And when it comes to the 3-layer model in Ethernet, the only layer that you can really use Ethernet with is the access layer, where the users are actually being connected to the access layer switches. Because the transmission limitations of Ethernet, since it runs at half duplex, and it offers a bandwidth of 10 meg per second, but of course, since you're not sending and transmitting, sending and receiving at the same time, you're not really getting the full effect of that 10 meg. The limitations, the built-in limitations to Ethernet, it's really not useful at the distribution and core layers. It could be used, but if you've got a campus network, once you get to your distribution and core layers, hopefully you've got lots of fast Ethernet. And fast Ethernet is defined in IEEE 802.3u, if you want to read up on the technical side of it. Fast Ethernet operates at 100 meg per second and it runs at full duplex, which means that it can send and receive at the same time. That makes the effective throughput of fast Ethernet 200 meg. And you can still use UTP wiring, but you can also use fiber. Now, fiber is still expensive, but it can be used for fast Ethernet. And what you may have seen on some Cisco switches and other devices in the past are what are referred to as auto ports sometimes, but they're actually 10100 ports. And these are ports that can run at 10 meg for Ethernet or 100 meg if it's a fast Ethernet connection. And to allow the negotiation of this port speed, the end devices need to be configured for auto negotiation or simply auto. Fast Ethernet also allows the building of fast Ether channels. And just a little look ahead for those of you who may not know what an Ether channel is. It is a logical bundling of trunk links. Because as you know in spanning tree, if we have 8 connections, 8 physical connections between 2 switches, STP is only going to allow us to use 1. And the other 7 connections are going to be unusable because STP will put them into blocking mode. So if we build an Ether channel, when we do that, it bundles it bundles the physical connections into one logical connection. STP sees it as one connection, but it's actually 8, and we get to use all 8 of them. So if we have all fast Ethernet trunk links, we can build an Ether channel that actually reaches a speed of up to 1600 meg per second, because we can put 8 separate connections in, and the effective bandwidth of a fast Ethernet connection is 200 meg. When it comes to the Cisco 3-layer model, you're looking at the access and distribution layers. That's where you'll see fast Ethernet used. Hopefully you can use it, hey, you've got a fast Ethernet connection to all your users. Doesn't always work that way. But at the distribution level, you'll definitely see fast Ethernet used for trunking. Now we're stepping up the ladder to gigabit Ethernet, usually referred to as gig Ethernet. And not much you really have to know about this for the exam. You need to know the speed it supports, of course, and the name is the recipe there. The cable type here depends on the standard of gig that you're using, so it's not something where I can just tell you, hey, you're going to use this cable type and that's it. Some of the more common cable types that you should know about are STP, shielded twisted pair, and fiber cables, particularly MMF, which is multi-mode fiber, with a 50 or 62.5 micron core, and single mode fiber with an 8, 9, or 50 micron core. Again, the operation and cabling of gig Ethernet beyond what I'm telling you here is beyond the scope of the exam, and I would suggest you do some research when you do get a switch that can run gig Ethernet about what kind of cable type you should use. Finally, we now have 10 gig Ethernet. And if you see this in documentation, it looks really strange. That's why I put it in the quotation marks there, 10 GBE. And I had to think about that for a minute because you certainly don't associate 10 gig speed with Ethernet. So the first time you see that, it will throw you. As far as gig Ethernet goes, you can only run it on fiber optic, and you can only use it obviously in full duplex mode. 10 gig Ethernet running in half duplex would not do you very much good. But you have to run this on fiber. You cannot use shielded twisted pair. So just catching you up there a little bit of Ethernet news you might have already known. And long-range Ethernet. This is interesting. It's referred to as LRE in Cisco documentation, and it uses pre-existing cabling to bring Ethernet to users who might not ordinarily be able to get it. And it really is interesting. I've done a little bit of reading on it, and you're usually going to use the phone cabling, which makes sense. Now, from what I've seen, the speed really depends on the cable length, and it can reach an effective speed of 5 to 15 meg per second. Now, obviously for this, you have to have some specialized switches to run LRE, and you'll see LRE actually in the names of the switches that can run this. So again, that's something you want to go out and see how it operates. Fantastic. I think that's a great idea. The actual operation of LRE is beyond the scope of the exam, but you should know that it exists, what it does, and the approximate speeds it can reach. It's a good idea to know that. But again, go right out to your favorite search engine, put long-range Ethernet in there, and you'll find a lot of good documentation out there to read. Now, a GBIC, sometimes pronounced Gbit by some folks. And what this is, it is literally a GBIC. It is a module that fits into a gig Ethernet port. And these modules are hot swappable. So if you are migrating to another gig Ethernet standard, you don't have to go out and get a new router. I mean, Ethernet is Ethernet and fast Ethernet is fast Ethernet. But when you get up to gig Ethernet, you've got different cable types. You're going to need something called a GBIC, and it's just a little tiny module that fits right into a gig Ethernet port. Now, off the record, even though I am saying this into a microphone, they're not always the sturdiest things in the world. You have to be careful with how you handle these. They're not fragile, but sometimes I know a couple of years ago when they really first got popular, they didn't fit really well. Sometimes you had to kind of work with them, but the ones that I've worked with recently have been very sturdy and worked out really well. But occasionally you'll just get one that just isn't going to make the grade. So that's what a GBIC is. It's simply a module that fits into a gig Ethernet port. It's an adapter, and thankfully it is hot swappable. So there's no shutting down, no reloading, no nothing. Cable review. For those of you, maybe it's been a while, just want to remind you of a couple of cable types you need to know about. If you're connecting your PC to the console port of a switch to communicate with it, you must have a rollover cable. Now, you know that's the blue cable that comes with every new Cisco device. It's the one all the engineers fight about when new stuff comes in. You got to guard that with your life because that's really the only way to communicate with it outside of Telnet. And if you have one of these, what you need to do now, though, because the rollover cable is unique, it's going to have a DB9 connector on one end and an RJ45 connector on the other. And the RJ45 connector is the little plastic snap connector. Looks like a phone jack. And you just plug that straight into the console port on the switch. That's not a problem. The problem can be that you've got a DB9 connector and you go to your laptop and you look on there and you go, I have absolutely no place to connect this. You probably need an adapter. When I say many laptops don't have DB9 ports, I don't remember the last new one I saw that did have one. So you need to get an adapter. You can get these adapters on eBay. You can probably buy them from your favorite cable company, whoever you get your cables from. I'm sure they sell them. If you need an extra rollover cable and don't have one, I'm sure you can get one of those on eBay as well. But I've bought adapters off eBay for these, and they're about $10. So they're not expensive, but you have to have it because otherwise you're just going to be sitting there not configuring the switch. Now, to connect a router or a PC or a server to a switch, you're going to need a straight-through cable. And that, of course, is where all the cables, the wires inside the cable, run straight through, pin 1 to pin 1, pin 2 to pin 2, pin 3 to pin 3, and so forth. And if the router has an AUI port, you're going to need a transceiver for that router as well, because you're going to have that straight-through cable, and you're going to have an RJ45 connector, and you're going to look at it and say, I wonder where this goes. Well, it'll have a couple places it can fit, but the AUI port is not going to be one of them. And plenty of older routers, especially 2500 series that I recommend for home labs, they have AUI ports. When they're sold to you, they say, oh yeah, they've got Ethernet ports. Well, they are Ethernet, but they're actually AUI ports, and they require an adapter. It's called a transceiver. It looks like a little box, fits right in the palm of your hand, and one end of it, one side of it, I should say, connects directly to the router, and the other side of it has a spot for an RJ45 connector, and you just plug the cable right into that. Works like a charm. And finally, repeat after me, to connect two switches directly for trunking, we need a crossover cable. Absolutely correct. You can take a straight-through cable and plug them in, and you're going to sit there for a long time waiting for those lights to turn green because it cannot happen. So, especially with the new switch models, when the ports are in dynamic desirable, which all the ports on the switches we've been working with in this course are, you just take your crossover cable, plug it into the two switches, and you don't even need to touch it. You'll see the light go from blank to amber, and then about 10 seconds later it's going to go to green. So it works like a charm, but you got to have the right kind of cable to make that work. Now, there's one more last part of the CCNA theory I want to review with you, and it's important that you understand this and what happens, because everything we do from here on out really builds on this. And that is the process that a switch uses to build its MAC address table in the first place. And I don't care if you call it a MAC address table, a CAM table, a bridging table, or a switching table, it's all the same thing. And you can make static entries in a switch, and I want to bring up a switch right now actually, and we're going to take a look at the MAC address table, because most switches, all your switches are going to have certain addresses on it that are reserved for the switch, and they're going to have static next to them. And here is a way to see them. We're going to look at the entire MAC address table first. And you can see we got a lot of static addresses. Now, I did not configure these. That's how plenty of static entries get there, is by manual configuration. But you'll also note, if you look at these addresses, let me get my marker working there. If you look at those addresses, you can see that they're consecutive. And there's going to be a block of addresses there. You don't have to worry about that for the exam, but I've seen plenty of people say, well, you know, where did all these static addresses come from? They're actually pre-configured on the switch. And if we go down, I hit the space bar to go down one screen. You can see we have a lot of static ones on here and only a few dynamics. So if you want to view only the dynamic ones, you can use the option here on the end for dynamic. Show MAC address table dynamic, and there you go. Because when you're troubleshooting MAC address tables, and that doesn't happen real often. You could go years without even looking at one, frankly, because what we're going to go through in a moment works so well that you really don't have problems with it very often. But if you want to look at only the dynamic MAC addresses, you need to use that command instead of wading through all those others. So let's talk about how that table got built in the first place, because like I said, if you've got a switch with 12 ports, you might say, well, you know, I've got 12 hosts connected to these 12 ports, and, you know, I'm just going to make static MAC entries for these things. You really don't want to do that. There's really very little, if any, reason to make a static MAC address table entry today, because you want the switch to dynamically learn them, because then when you move those hosts, and I guarantee you that day will come, you're going to want to move those hosts to another switch, maybe just to get the old one fixed. You're going to move these users sooner or later. You do not want to spend your valuable time saying, okay, I got to go in the new switch now and I got to get rid of these old static entries and put in the new ones. You do not want to do that. Let the switch do this work. Let the switch build a MAC address table. Now, when you first power the switch on, that MAC address table is going to be empty, and of dynamic entries, I should say. And the switch builds its table dynamically by examining the source MAC address before deciding what action to take with the frame. It does not look at the destination first. We're just going to walk through, well, there are four possibilities actually. The destination MAC address is an unknown unicast, and this is after it looks at the source. It's going to look at the destination MAC then and say, okay, this is a unicast frame, but I don't have an entry for this address. That frame is going to be flooded. It's going to be sent out every port except the one it came in on. The second possibility is the destination MAC is a known unicast, and that frame will be forwarded only out the port that the destination host resides on. Makes perfect sense. Now, the third possibility is that the destination MAC is a known unicast and the source and destination reside off the same port. That frame is said to be filtered because it will not be forwarded at all by the switch, because the switch knows that the destination already saw it on the Ethernet segment, because Ethernet is a broadcast medium and every device on the Ethernet segment is going to see it. And then finally, the destination MAC is a broadcast or multicast, and in that situation, the frame will be sent out every port except the one it was received upon. Okay, so what we're going to do is actually walk through building a little MAC address table. And in this case, I'm not going to put the MAC addresses of the three hosts, A, B, and C there. We'll just assume that host A's is all A's, B is all B's, C is all C's. A and B are found off a shared segment on port 01. C is plugged in to its own switch port, port 02. So we have two collision domains here. A and B can send data that can actually collide. C cannot because it's connected to its own switch port. Now what happens here, first we're going to send a frame from A to C. And the switch will receive that on port 01. And the first thing it does is it looks at the source MAC address, which in this case is the all A's address. And the switch asks itself, do I have an entry for this device in my MAC address table? And the answer is no, we just turned the switch on. So what will happen is, and you can see it right here actually, the switch will make an entry with that MAC address and the port number it's found off of and make that entry in its MAC table. I'm going to leave the word dynamic out here. So that's the very first thing that's happened here. That frame has not begun to be forwarded yet. But now the switch has to ask itself, okay, do I have an entry for host C, this all C's MAC address? That's the destination. No, because it's destined for one host, but it's unknown where it is, so it's an unknown unicast. And that frame would then be flooded. Now when C answers A, it's going to be a little different. C is going to respond to that frame. And the first thing the switch does, it is examines the source MAC address. Says, do I have an entry for the all C's address? Well, no, I don't. So I'll put one in, and I find this address off FAST02. Now the next question is, for the switch, do I have an entry in my address table for the all A's MAC address? Yes. So that is a known unicast, and that's going to be sent out port 01. And of course, this switch could have 10 other ports. It could have 38 other ports. We don't know. But already, just that fast, the switch has learned where A and C are. So instead of flooding frames destined for these two devices, it can then just unicast it. So it'll learn these addresses quickly. The addresses stay in the MAC address table by default for 5 minutes. That's the MAC aging time. If the switch at this point did not hear from host C for 5 minutes, that entry would be removed. So we've got our flood for an unknown unicast. We have our unicast for a known unicast address. And now let's assume that at this point the switch has a full table. And B sends frames to A, or sends data to A. Frames are going to hit the switch. But A and B are also on Ethernet. They're on an Ethernet segment, and that again is a broadcast medium. So everything that B sends out is going to be seen by every device on the segment. So when the switch sees the entry, first it's going to say, okay, I have an entry in my MAC address table for the all B's address. I know where host B is. So then it's going to look up the destination of host A and see that it is found off the same port. And in that case, the frame is said to be filtered, because the switch sees that the host and the source and the destination are found off the same port. So in that case, it would be filtered. There's no reason to forward it. We don't get to say never in this business very often. You know, this will never happen. There's always an exception, except with Cisco, where there are 200 exceptions, it seems sometimes. But there's no exception to this rule. A frame can't go back out the same port it came in on. It can't. So we've got one more possibility there, and that's a broadcast or multicast. You're going to be introduced to some multicast MAC addresses later in this course when we're actually talking about multicasting. You don't learn any of those in the CCNA, but the one you better know right off the bat is the broadcast MAC address, and I'm sure you know what that is. That's the broadcast MAC address, the all F's address. Of course, these are in hexadecimal. If you're a little rusty with hexadecimal, if you got past the CCNA and you didn't master hexadecimal, I understand that. You can visit my website, and I've got a good hexadecimal tutorial out there to catch you up on. But again, the letters, you'll see these occasionally expressed. Cisco likes to do this. They will express hexadecimal values in capital letters in a lot of their documentation, and that does not affect the value. I have found some people think it does, but a capital A and a lowercase a and hexadecimal mean the exact same thing. So that's how a switch builds its table with source MAC addresses. Now there are other reasons that a switch looks at the source MAC address first. One is port security, and we will talk about that later in this course. where the source MAC address serves as a password. And you're also going to see some other reasons throughout the course why the switch considers the source MAC address before even looking at the destination. Now, back up on the switch, you see that we took a look at the Show MAC Address table options, and if you work with switching a lot, you'll want to get used to some of these. But especially dynamic, that's almost the only one I even use regularly out of that, is to see the dynamic MAC entries. Just as a quick review, you know how to give a name to a switch is with the host name command. And we'll just name that switch 1 just for fun. Now, sooner or later, you're going to need remote access to switches. And in this particular course, several of the lectures we're going to run are going to be on multi-layer switches, more popularly referred to as layer 3 switches. And these are switches that have routing capability. And with those, you can send pings and get them back. You can run routing protocols, create static routes, the whole bit. And with layer 2 switches that you worked with in the CCNA, you were not able to do that. And there's one interface down at the bottom of all of this that you need to be very familiar with, and that is that VLAN 1 interface. And if you want to allow Telnet access to your switch, that's where you need to assign the IP addresses on interface VLAN 1. And you do it just the same way you do any other interface, just with the IP address command. And as you continue your CCNP studies and then go off into more specialized study, you're going to see a lot of uses for that. It's kind of like the loopback address. You learn about it and at first you go, okay, that's cute, why do I need that? And the more you study Cisco, the more you see why you do need loopback interfaces and loopback address. The same goes for VLAN 1. But the key for us right now is that VLAN 1 allows us to assign a switch and address for remote administration. Now, something else we got to do is we got to set a password for Telnet, right? If we're going to have people Telnet in, thankfully the Cisco default is you must have a password set for Telnet. I think that's a great idea. I'm sure you do too. We don't want people just telnetting into our routers whenever they feel like it. A couple of differences I want to show you though between switches and routers. I'm going to thumb all the way to the bottom again here. Note how many lines this switch has. Remember with your routers during your NA studies and even during your advanced routing studies that there were 5 simultaneous telnet connections that could happen at one time? Because you had 5 lines, 0, 1, 2, 3, and 4. Well, here you've actually got 16 lines. If you ever want a really good time, have 16 different people telnet into your switch to work on a problem. They're going to be there a while. I don't recommend you have that many people telnetting in, but you do need to set a password to allow this. And just as a review, if we wanted to set a single password for all of these, we could do it just like this. And login. It does not matter what order you enter the login and password commands. I see a lot of discussion about that, almost too much out there on the net. It does not matter which one what order you set it in. As a matter of fact, let's see if we can replicate the issue that I see people getting a tizzy about. Yeah, that's it. Because if you type login in first, you get this message, login disabled online, and it's going to list every single line. And the first time you do that, and you're a beginner, and I've been there, you know, I've never forgot what it's like to get started with this stuff and go, oh my gosh, what have I done here? I disabled login. Well, you need to remain calm and read the whole message because it says login is disabled until the password is set. And then you do that and it's fine. So again, it does not matter in what order you place those in. Now, one thing that I do on my access switches is something you may consider on your production switches, and it's a good thing to do in a home lab as well, and that is to assign privilege level 15 to Telnet users. Now, this may not be something you want to do at production, because if you recall from your Telnet study, when a person logs in or telnets into a router or a switch, by default, they are placed in user exec mode. And that's fine, but they can't really do anything there, which may be your point, except I don't want anybody telnetting in if they shouldn't be in privilege mode to begin with. You know, if they can't handle privilege mode, I don't want them in the router or switch to begin with. But then they've got to enter another password to go from user exec to privileged exec. Remember that, the little enable password trap? Because it's going to come up and say, oh, you need to enter an enable password, but one hasn't been set. This is how to avoid that. You just go right under your lines and you assign a privilege level of 15. First you have to learn how to spell privilege like I just did. But you just put privilege level 15 in. This is a great command, especially for home labs, because you're going to get tired of getting kicked out to user exec mode or having to enter an enable password every time you telnet in. And when you put in this password, this means that any user who telnets in right now and supplies the correct password, of course, will be placed immediately into privileged exec mode. And when you're working on your security studies, you're going to see, I mean, that privilege level 15 isn't coming out of thin air. 15 is the highest level, and it's pre-configured by Cisco. And privilege level 0 is the one that puts you into user exec. You just don't see that in the configuration. But you've got a lot of custom lines in the middle there that you can configure. Don't worry about that for this exam. We're not going to get into that. But I do want you to see that privilege level 15 command. And no matter what, you can set a console password, you can set an enable password, you can set any password you want, except the VTP password, remember. And service password encryption will encrypt that password. Just a reminder there. Now, you're going to move some files on a Cisco switch sooner or later. And the copy command can be a little awkward at first, and I just want to spend a minute here reviewing that, because it's a good multiple choice question too, and you don't want to be sitting there thinking, oh, is it copy to and then from, or from and then to? Just remember, wherever you're copying from, and actually we don't even need to be into that, copy, that's a lot of choices to begin with, right? I mean, that is a lot of choices. Let me run it again because we got caught with a console message there. That is a lot of options for copy. And most of the time when you're copying on a Cisco switch, you're going to be copying your config, your startup config, or perhaps your iOS version to a TFTP server as a backup, your iOS file as a backup. Just note that with the copy command, with the first one, you're copying from somewhere. And then for the next option, you're copying to somewhere. So we're going to put startup config here, and this is where you're copying it to. And it's going to ask, yep. So if you type in copy startup config, and then where can we back that up? You can actually back it up to a web file system. You can back it up anywhere you want, most likely to a TFTP server. And then it's going to ask you, it's going to ask you, where is this server? So we're not going to go into all of that. But what I want you to note about the copy command is that the first thing you put in after copy is where you're copying it from, and then right after that, where you're copying to, because that can be a little confusing on a multiple choice question. Now here I talk about deciphering iOS file names, and Cisco may not want me to use that word, but let's just take a look at that mess that I put right under there. I mean, C2950, I6Q, 4L2MZ, 121, 19, EA1 bin. Okay, that's fine. That actually means something, though. It's a good idea for you to know how to decipher this or how to break it down. And the first part of it is very straightforward with C2950. The C stands for Catalyst, and that's a Catalyst 2950 switch that I took this off of. And after that, the part that begins with the I describes the feature set that's running on this router now, or switch. When you're purchasing new routers or switches, or actually even used ones for home labs, you need to inquire about that feature set, because that determines what you can and cannot do with a router or switch. Sometimes people are amazed to find out that they buy a router and they can't do everything with it that Cisco has in their documentation. Some of the stuff you don't want to pay for. I mean, if you get a more advanced feature set, if you buy one with an enterprise feature set. It's going to cost you more than one if you buy it with just a plain IP feature set. Again, this is something you can go out to that site that I keep mentioning, cisco.com/universecd, and just do some Google searching or your favorite search engine searching as well to see what the different feature sets offer. But a router is not a router is not a router. They're going to have different capabilities. Breaking the rest of that down, the 121 you see indicates the major iOS release version. In this case, that's 12.1. The 19 is actually the maintenance release. The E indicates an early deployment of some features. The A indicates the interim build level. The 1 indicates that this is the first build of that particular interim build level. And the bin indicates that this file is a binary executable. I'd be surprised if you saw any of this on your exam beyond maybe the basics, the 2950 and the bin. I would not spend too much time trying to memorize all of this, but I think it's a good idea for a CCNP to know what the heck a file name is. What does this E mean? What does that A mean? I tell you, it's also a good job interview question, and I've been on both sides of that. So, we'll take a look at some more admin features that I think will really help, that I know actually will really help you out. And there are a couple of commands here. One that really surprises people, and that is the interface range command. Because I can guarantee you that sooner or later you're going to have some configuration, could be, in a CCIE practice lab or the CCIE lab itself. And it could be on a production network where you need to change the mode of 48 ports on a switch. And you don't, maybe you're, a bubblehead there on the job thinks you need to do that. Oh, we need to change the mode of this. And you don't want to sit there and go interface fast 01, change it interface fast 02, change it. You're going to be there a long time. So let's see, how many ports have we got on this particular switch? 24, I believe. Yep, 24 fast Ethernet ports. So let's say for whatever reason we needed to change the speed of all of those ports to 10 meg and the duplex to half duplex. Well, you don't want to sit there and go into interface configuration mode 24 times. You want to use the interface range command. And if you want to configure a group of ports with a given command all at once, this is the command you want to use. Can be a little tricky to get started with. Let's try interface range, because you might have thought, let's see, is range, yeah, the range command is in there. Because when you run iOS help here, you're used to just seeing a huge list of interfaces. And there's that long reach Ethernet that I talked about earlier in this lesson. So we go down to the bottom here, though, and we see some other commands, and range is one of them, and that's the one we're going to use here. So we're going to specify an interface range of fast 01. Let's see what iOS help tells us there. Yep. Through 24. Now, like I said, you can use commas here. You can use dashes. Some iOS versions want you to leave a space between the characters. Others do not. I believe we could put a comma right here. Actually, we can't. So it takes a little getting used to as far as if the range was actually 1 through 6 and then 8, 10, 12, 14, 16, by listing them individually. But here, we're going to use the interface range command for all 24 ports. And notice that the prompt, instead of changing to config IF, changed to config IF range. So now whatever we put in here is going to affect all 24 ports, so you better be real sure you want to do it. And what we're going to do is change the speed of them all to 10 and change the duplex to half, and we're going to get a whole lot of messages here about that, a lot of complaints. This is why you want to practice these things on a home lab. We're just going to wait for those line protocols to quit bouncing up and down. And now we'll go ahead and save our work, get in the habit of that. And now you'll notice that every one of these has speed 10 underneath of it. This particular model does not show you the duplex, but there you go. So that is a great command to get used to. It's amazing how few people actually know it's there. Because if you needed to change, say, all the trunking modes for 6 ports, I mean, why go into 6 different ports individually when you can just do it for a range? So it's a good command to get used to, especially if you go after your IE. So that's your interface range command. Just as a reminder also, you can also describe what a particular port is doing with the description port command. And we'll use the range command here again. And we'll do 1 through 5. We're going to use the description command to just say trunking. Let's say these were trunking ports. And let's see what we get. And there we go. We've got the description trunk ports. We did actually have to do a write there. And most of the switches I've seen, we don't have to do that, but no big deal. And that's how you do it. So if you want to assign anything to multiple ports, get used to using that interface range command. It'll make your life a lot easier. And describe what you're doing with your ports. Not a bad idea for those of us who have to follow you. So that's how we use the description command. And there's one more very helpful command here that I want to run by you. And it's auto recovery from the error disabled state. A port goes into error disabled state, and it's going to look like ERR disabled when you do a show interface. And it can happen for a number of reasons. It can happen when you're configuring an ether channel and you don't do it quickly enough. You get an encapsulation mismatch and the port goes into error disabled state. And the link light on the switch will actually go out. It also happens with port security if you are in shutdown mode. And that's the default for port security. So if someone tries to connect to the switch with a non-secure MAC address, the port will shut down and it'll go into error disabled state. And you have to re-enable it by shutting it and reopening it. But that can happen at 1 in the morning, and maybe you're in a scenario where you need that port to come back up after a few minutes instead of somebody calling you. You know, that's a judgment call. But what you can do is use the error disable recovery interval command. Let's see that one in action. And we've got detect and recovery choices here. We're going with recovery. And the one we're really interested in right here is interval. And what do we always do when we're about to enter a command that involves units of time or bandwidth? We're going to use iOS help to see what the value is. And here it's in seconds. So if we want that port to reopen in 5 minutes, we're not going to enter a 5 here. And I've seen people do that. You enter 300 because that's how many seconds you want it to be. So again, the error disable recovery interval command, I'm showing you that for the exam, but I'm also showing you that for the real world because that's a judgment call. If you have a port that goes into shutdown mode, but you think it's got to be reopened in 10 minutes and you don't want to be called or you may not be available, then you might want to make the call to use this command. But notice that it's a global command. It's going to work on all the ports. Now, during your CCNA studies, you may or may not have been exposed to an ether channel. And if not, don't worry about it. We're going to hit the basics right off the bat when it comes to ether channels, because some CCNA books out there and some curriculums, some boot camps leave this topic out unbelievably. And it's unfortunate because A, you're going to see some of it on your exam, your CCNA exam. And secondly, there are ether channels in just about every network you're ever going to see. So you've got to know what they are to support them, obviously. You've got to know what's going on, and you got to be able to troubleshoot them, because it's the kind of thing that once you build it, if you just leave it alone, it's probably going to be fine for years. But you know, there's just no leaving things alone for some people. You know, they're going to change some settings, and you have to know how to get it back. So before we talk too much about troubleshooting an ether channel, let's talk about what one is to begin with. And an Ether channel is a logical bundling of 2 to 8 parallel Ethernet trunks. And this bundling is also referred to as aggregation. And an Ether channel has several benefits, and it's one of two ways to use all the paths, the physical paths, the trunks, between two switches. Now, if you don't know what the second one is yet, that's fine. You're going to see it in our advanced spanning tree discussion. But before we talk about advanced spanning tree, let's talk about some basic spanning tree. We have two switches here, switch 1 and switch 2. Switch 2 is the root for all VLANs. And if you're a little rusty on your spanning tree, don't worry, because we're going to review that later. But right now, let's see, right before we keep going, try to look at this diagram and tell me which ports are going to be blocked and which ones are going to be in forwarding mode, because that really has a lot to do with why we create an Ether channel to begin with, because there are two major reasons we do it. One of them is to make all these paths available for transmission, and the other is to avoid that 50-second wait when the single path goes down. Because right now with switch 1 and switch 2, with switch 2 being the root, all 4 of these ports are going to be in forwarding mode. All of the designated ports, which is what these are, on the root bridge are going to be in forwarding mode. So that's fantastic, you think, and it is, but the problem is on the non-root switch in this situation, only one of the ports will be in forwarding mode and the other 3 are going to be in blocking mode. And this is, again, the default. This is what spanning tree is going to do. Now there's a reason for this. Spanning tree does this to avoid switching loops from forming. So even though we have 4 physical trunks between these two switches, we can only use one path. Now that's already ticking me off, because I'm looking and thinking, man, look at all the bandwidth we're wasting here. We're only using 25% of our potential throughput. So that's one problem. But the other is that if that connection goes down, the one that's being used goes down, the switches are going to take almost a minute to recover from that. Because first off, if you recall, there's a 20-second wait right off the bat, because it's going to take that long, and we'll just remove this one. We'll just remove that particular connection, and now switch 1 and switch 2 agree that the next path down is the one they're going to use. But that does not become available immediately. There's going to be a 20-second wait before that port on switch 1 even begins to come out of blocking mode. So there's a 20-second wait there, and meanwhile your phone starts ringing, your cell's going off, your pager's going off. But we're not done yet, because then we've got 2 more 15-second delays built in. Because the port is going to spend 15 seconds in listening mode and then 15 seconds in learning mode. These are all built-in default delays. And they are there for a reason. They're there to make sure that switching loops do not occur during this changeover. But you can already see the problem, if you've ever worked in a network in your life, and we all have, that you already see the problem, that for almost a solid minute, there's no communication between these two switches. There's no data being transferred, I should say, from switch 1 to switch 2 and switch 2 to switch 1. And by that time, boy, everybody is calling you wondering what's going on. So that's a problem with spanning tree, and when you create an Ether channel, that helps you get around it. And we're going to put this link back on the board. And what an Ether channel does. An Ether channel is a logical bundling of 2 to 8 of these connections, just like this. 2 to 8 trunk lines. And that's all fine, but the best part is that spanning tree considers this to be one logical connection, or one physical connection, I should say. So the 4 physical connections are bundled into an Ether channel, and spanning tree only sees the Ether channel. It does not see the individual physical links. And as you're going to see when we build an ether channel in this lecture, you're actually going to see that spanning tree just thinks there's one connection there, period. So in that case, in essence, all 4 of these paths are then usable, and if one of them goes down, the other 3 are still going to be there to pick up the slack, and there's none of this waiting. These are gone. And any data that was traveling over the link that went down, it's going to be rerouted onto another one of the links, and it is a matter of milliseconds. It's not even seconds. It's milliseconds. The only way that you'll even know it happened, that a port went down, port went bad, cable got disconnected, whatever happened there, the only way you're going to know it is if your networking monitoring software tells you, or you happen to see that the link light went out for the physical connection. But your average user, depending of course on how much bandwidth you have, your average user and some average network support personnel aren't even going to notice it. So we've got 2 great benefits right off the bat with an ether channel. First, that Spanning Tree considers this to be one link, and that when one of the physical links inside of it goes down, there is no cutover time of 50 seconds. There's no time, there's no downtime at all. You can't beat that. So let's take a look at that actually on our rack, I believe. Yeah, we'll talk about those protocols in just a moment. But right now, I have 2 switches that are connected by 2 physical links, FAST011 and FAST012, as you see here. And we're actually going to start over on another switch. So let me go to switch 1 and run show spanning VLAN 10. And this is going to confirm a couple of things that I just mentioned to you. And if, like I said, if you're rusty on how this switch got to be the root, don't worry about that. We're going to take care of that during the spanning tree lecture. But as a CCNP candidate, I know you understand the basics. So what we've got here is, first off, this bridge has been elected the root. And we can always tell just by looking at that. We see that there are 2 connections to the remote switch, FAST011 and FAST012. Both of them are in forwarding mode because they're both designated ports. We can also run one of my favorite commands that people tend to forget about, show interface trunk. And you can see here, we talked about this during the VLAN discussion a bit, that this is going to show us what ports are actually trunking. So right now, on switch 1, FAST011 and FAST012 are both in forwarding mode. So let's take a look on switch 2. Show spanning tree for VLAN 10. This switch is not the root because you don't see a message here anywhere saying this switch is the root. But also you can see that while it's also connected FAST011 and FAST012, one of the ports is in blocking mode. FAST012 is in blocking mode. So right now the only trunk that is being used between these 2 switches is the one that's been built over port FAST011 on each switch. So we're going to stay over here on switch 2 and we're going to shut down FAST011. We're going to see if we can spot some of the modes that 12 is going to have to go through. And that's a message that went administratively down. You can see right there it's already in listening mode. 011's not here anymore because we administratively shut it down. And FAST012 is in listening mode. So right now there are no frames going over that trunk. See if we can spot it in learning mode. Hey, I'm getting good at this. Now it's in learning mode about 15 seconds later. And now we still don't have any frames going across this link. And these are the timers that are affecting the entire thing. The hello time, the max age, and the forward delay. The switch is supposed to wait 20 seconds in max age before it begins even going from blocking to learning. Sometimes it doesn't work that way. Theory doesn't always work out with the real world, but theoretically, we've got a 50-second delay. By this point, I think we're going to see the trunk is up. Yeah, it's in forwarding mode now, and everything's fine, but we did have that time where the trunk was unavailable, that we could not send any data over the trunks at all. So we'll go ahead and open that port back up. And this is why you like having a home lab, because you do this at work, you're going to get fired and or sued, so don't do it. So we see fast 011 come up, and everything will just be fine in just a second, and 011 will be the root port again. Let's look at show spanning VLAN 10. While we're here, you can see that 011 is in listening mode. Just a little spanning tree. It's already in learning mode, and you can see that 012 went into blocking mode now. And it's still in learning. And pretty shortly it's going to come out of that and be in forwarding mode. So you see that one of the problems right there. So when we configure an Ether channel, that problem is going to be eliminated. Now that's the Ether channel theory you should have had in the CCNA. If you didn't have it, I'm glad I could bring it to you and show it to you in action. And you can see why they're so helpful, and you'll see that even more when we actually configure one here shortly. But there are some details that you didn't learn in your earlier Ether channel studies regarding the negotiation of an Ether channel, because we do have protocols that are going to negotiate an Ether channel when we put in a very simple command here shortly. And the first one of the two protocols that you need to be more than familiar with for the exam and the real world is PAGP, the Port Aggregation Protocol. And this is the Cisco proprietary protocol. I should not say standard there. Let me get rid of that. Maybe a little confusing. So we'll call that a Cisco proprietary protocol. And again, of course, that means that if one of your switches is Nortel or Juniper, and the other one's Cisco, and you want to make an Ether channel between the two, you cannot use PAGP. Now, PAGP packets are sent over ports that have been configured to become part of an Ether channel. No problem there. Two values have to match for these devices to become part of an Ether channel. And this is good for the exam and the real world, because configuring the Ether channel is probably the hardest part. It's probably the part where you do the most troubleshooting. The first that must match is the remote and local port group numbers. And you're going to see the command for an Ether channel involves something called a channel group. And that's going to have a number, and we can assign it any number that we want to, but it's got to match on the remote port. We can't put the local switch port 011 in group 5 and then put the accompanying port 011 on the other side in group 10. They're not going to become part of the Ether channel. And the device ID on all remote ports must be the same. That does make sense, doesn't it? Because if you are trying to create an Ether channel from your switch to two other switches, that's not going to work. Ether channel has to be between two switches. There's no such thing as a triangle there. You can't do that. Now, Port Aggregation Protocol has the capability, and I stress the word capability, of changing a characteristic of the Ether channel if one of the ports inside the Ether channel changes. That characteristic, maybe speed would be a characteristic we could look at there. Native VLAN for that port, then the Ether channel would adapt. I'm going to tell you, I wouldn't bet, not only would I not bet a week's salary on that, I wouldn't bet a week of your salary on that. Capability is the key word there. That's not always going to work that way. As you're going to see in the little troubleshooting section I have for you at the end, you should beware of changing characteristics of ports that have been put into an Ether channel, because once you get the Ether channel built, that's the number one problem spot. Someone says, oh, okay, we need to change this native VLAN setting on this port. Well, if it's in an Ether channel, you better change them all, or you could have a real problem. PAGP is supposed to be able to adapt to that. I've seen it not do so. And the other negotiation protocol we're going to talk about will not adapt to it. So that's something, I'm telling you this because this is the official Cisco theory. It's in their documentation, but it does not always work that way. And I would not change the characteristics of some of my ports in an Ether channel. You really want the configurations to be standard. Now, PAGP, as we're going to take a look here on the rack in just a few minutes, it's got two modes that it runs in, dynamic and auto. And this is the other problem that you're going to have possibly when configuring an Ether channel, especially for the first time. If you get cute with these modes, if you put auto on each side, you already know, I'm sure, just from the name of that it's never going to come up. Because dynamic means the port is actively attempting to negotiate an Ether channel with the remote side. Well, if auto, of course, means that it will become an ether channel as long as the other port initiates it. Well, if they're both in auto, then they're both just going to sit there for a long time waiting for the other one. So watch that in configurations. I've seen that more times than you would suspect. Well, that's PAGP, and this is the other ether channel negotiating protocol, LACP, Link Aggregation Control Protocol. This is the industry standard. So if we have a multi-vendor environment, this is what we have to use. If you would like to read more about it, it's defined in 802.3 AD. What LACP does, it actually assigns a priority value to every port that you configure with ether channel capabilities, and it allows for the creation of standby EC ports. And let's put that on the whiteboard, because that sounds just a tad strange, doesn't it? It's like, well, you know, I can put 16 ports in an ether channel on a switch, but I can only have 8 of them active. Yeah, and this is why. Just going down the side here. Let me get rid of that too, because it does sound a little confusing. Let's say that you have 10 ports on 2 facing switches that are actually trunking. You can configure all 10 of them to be in an ether channel with LACP. Now, not all 10 of them are going to be placed into the ether channel. Only what the LACP considers to be the best 8 ports. And the value for that is actually the lowest port priority. And if you're not terribly familiar with port priority, you will be after the STP lectures. But the lowest port priority of the lowest 8 would actually be bundled. We'll just say, for the sake of argument, that's 1 through 8. So right now, ports 1 through 8 on these 2 switches are in the ether channel. Well, if one goes down, literally in this case, if line 1 goes down, excuse me. So 1 goes down, and we'll just take that out. If one of the trunks fails, what LACP will actually do, if you've got extra ports configured to be part of the ether channel, is LACP will dynamically say, okay, you know, we're missing one of our trunks. Let's pick the next available trunk, the one with the lowest port priority, and put that in the ether channel. So if you have a situation with Cisco switches where you have the capability, say, to have 10 trunks running, I would run LACP, because you can configure all 10 ports to be part of an ether channel. The best 8 will be selected, and then if one of those 8 goes down, LACP immediately takes one of these standby ones, so to speak, and standby trunks, and makes it part of the ether channel. Now, that's a pretty good deal. That's one thing that PAGP does not do. Talking about modes, LACP has active and passive modes, and again, ports configured in passive mode are waiting for the remote port to begin the process. So again, do not put both ports in passive mode. If you do, you're not going to have an ether channel form with that trunk. They've got to either be, one of the 2 ports has to be in active mode. Now there's a third option. If you're a quick reader, you might have seen it fly by there. The third option for ether channel is just on. And that's the one I tend to use, and that's the one I see unless I've got a real reason to use LACP. I will just use on, which means there is no negotiation. They're just going to be put into an ether channel. So again, for your average ether channel situation, this is the one I choose to use. But you need to know all about those 2 negotiation protocols for the real world and for this exam. So let's take a look then at configuring an ether channel. We'll bring the rack back up. And we're going to configure an ether channel using both of these ports, and then we're going to shut one of them down again so you can see what does or does not happen with that. At first, conf-t on interface fast 011 on this side. Let's look at the channel protocol command. This is the command to choose one particular negotiation protocol. So if you want to use LACP, you need to use the channel protocol command. If you want to use PAGP, you need to use Channel Protocol PAGP. It does not have any options after that for either one, I do believe. LACP might. Nope. So we are going to configure this for LACP. So far, so good. We've told ports 11 and 12 on switch 2 that we are going to use LACP. Now, to actually place the port into an ether channel, to place the trunk into it, we've got to go back to our interface, and we are going to use the channel group command. So we've got channel protocol and channel group, and here's that group number I mentioned during the last few minutes, where I said this is a number that has to match between the local port and the corresponding remote port. So we're just going to use group number 1 here. And let's keep on using iOS help. So we've got mode, and here we've got 5 modes. And you can see that for LACP, the choices are active and passive. And for PAGP, they are auto and desirable. And again, just watch this. Don't outsmart yourself. Don't make both sides auto. Don't make both sides passive. Just pick. I always put them both. If I use LACP or PAGP, and if I were in your shoes, I would always just put it in either desirable or active. So we're going to pick, since we already configured it for LACP, we're going to pick active. And that's it. And you can see that it's creating a port channel. And you also see the line protocol go down. You should get used to that because that's going to happen here. And then you see the link protocol come right back up. So don't panic when you see the link state, or the link protocol, I should say, go down. And same thing's going to happen to 12. I'm going to go ahead and wait for that. It only stays down for about 8 or 9 seconds. Hopefully. There we go. So let's do a quick save and a show config on this side and see what's going on. Because sometimes all those messages kind of gets in the way. You see right up here at the top of the configuration, this interface was not here before. This interface port channel, that actually represents the ether channel. And what's great about these on multi-layer switches, you can actually configure an ether channel and give it an IP address. That's more of a CCIE level deal than anything else. It's not something I see a lot of. But you can create an ether channel that has its own IP address. Pretty cool stuff. There's always something else to learn. We see down here at FAST011 and FAST012, I used channel protocol LACP and then the channel group 1 mode active command. Let's take a look at what the interface states are right now. Let's see what we see. Whoop, that's not what I wanted. Let's try show interface FAST011. And everything looks good right now. Well, there's the Ethernet port, line protocol is up, everything's fine. That's really what we want to see. I mean, obviously there's a lot of output with this command. And we'll use our up arrow, go back 1, and we're at 12. Same thing, so the line protocol went down for about 9 seconds according to the timestamp. And the line protocol is now up. And keep an eye on that for troubleshooting. That's a good thing to mention. As you've always got that timestamp there if you have timestamps enabled. So let's go over to switch 1. Let's do a show interface FAST011 on this side. Everything looks good so far. The line protocol is still up. 12 I'm sure will be the exact same way. We'll take a look at it anyway. Never hurts to look, and there, yes, we see the line protocol is up. So even though we've got the ether channel configured on one switch and not the other, everything's still fine. What about the trunk, though? Trunk still looks good. Let's go back to switch 2 and take a look. Everything looks good, but you see the ether channel hasn't really been built yet because we're still seeing the individual ports. We're going to go over to switch 1 on those corresponding ports. We're going to use the channel protocol command first. Set it for LACP. And there we see iOS help again, reminding us what we need to put in here. We're going to put active for that one. You see the port channel interface being built. Line protocol goes down. Line protocol comes right back up. And there you see line protocol on interface port channel 1 change state to up. So we're in O12. I'll use the up arrow to repeat my last few commands. Channel protocol LACP. And then the channel group 1 mode active command. So we're going to let the line protocol sort itself out there. And give it a second. And everything looks good so far. We'll do a quick save of our work. Let's check that interface out. Yeah, everything's still good. Line protocol is up. You want to watch this. The reason I keep coming back to this is that under certain circumstances, if you get interrupted and you take too long to configure an Ether channel, what can actually happen is that the port can become error disabled. And we talked about that earlier about what we have to do. You've got to reopen the port manually. I see that once in a while with people who use my remote racks. They'll start an Ether channel but not finish it. They come back and they go, I finished the Ether channel, but it's not working and I don't have a trunk anymore. Well, what happened is your port went into error disabled state. And that's an occupational hazard with an Ether channel. So that's why I kept checking the interfaces there. So far it looks like we're fine. We're going to do a quick show interface trunk, and look how different this looks all of a sudden. Under show interface trunk, we no longer see FAST011 and FAST012. We see PO1, and that PO is short for port channel, and that is what was created when we built the Ether channel. The Ether channel is actually considered a logical interface, and it's port channel. And again, in more advanced studies, you'll actually give that an IP address. You can actually do a show interface port channel 1. And you actually get statistics for the Ether channel. You can even see, what the speed is. It actually has its own MAC address. Pretty cool, huh? You can see what ports have been placed into that channel. Good stuff in there. So let's do an escape and get out of there. We'll go over to 2. I always like to do show interface trunk on both sides just to make sure everything's okay. Because every once in a while you won't see the port channel on one side or the other, and you've made an error in your configuration somewhere. But again, under show interface trunk, we no longer see 2 physical trunks. We see 1 logical trunk. And that's what an Ether channel is all about. Now earlier, we were looking at the spanning tree for VLAN 10. And we saw that 011 was open on switch 2, which is not the root bridge. We saw that FAST011 was in forwarding mode and 012 was in blocking mode. But now we don't have those either. Under interface, down at the bottom of that output, the only thing we have is a root port PO1 port channel 1. And notice that the cost actually changed a little bit. Great stuff. So let's go over to router 1 now, switch 1, run the same command. Same thing. So now, spanning tree sees 1 logical connection between the 2 switches. So right now, we're actually using both physical connections to send frames between these 2 switches, where before we could just use 1. So that's one huge advantage right there. But let's go back over to switch 2 and see the other advantage in action. Remember before we shut down port 011 and 012 eventually came up into forwarding mode, but it had to come out from blocking to learning to listening? Well, let's try that again now and see what happens. Notice you don't see anything there about the port channel going down. It's because it didn't go down. It's still in forwarding mode. Now, obviously, we just cut its bandwidth in half, I'm not saying that Ether channels are so good that we don't have that problem. But you see here that we never lost connectivity between the two switches. We lost some bandwidth, but an Ether channel is considered to be a single logical connection, not only by us, but by the spanning tree protocol itself, and therefore, when one of the links goes down, we don't lose connectivity for 50 seconds. I have those commands here for you on the whiteboard, or at least to select a particular negotiation protocol. And I mentioned that the channel group command is used to place a port into an Ether channel. And not only do Ether channels do a great job for us as far as avoiding that 50-second delay, as far as allowing us to use all the available paths and bandwidth that STP prevents us from using, but once you get it built and once you've got it running, if it's left alone, it's going to run perfectly. You'll never have any problem with it. But the problem is, sooner or later somebody changes something they shouldn't have, or they're on the wrong port or on the wrong switch. You know the drill. So I've got a couple of real-world troubleshooting Ether channel suggestions for you. Couldn't hurt for the exam either. Let's take a look at those. First off, port attribute changes can bring Ether channels down. What you want is consistency on the ports that are forming the Ether channel. They should be the same speed, the same duplex, they should have the same native VLAN, and frankly, they ought to have the same everything else. You really want them to be as consistent as possible. And if you have ports running at different speeds or different native VLANs, not only will you might not be able to build the Ether channel, but if those changes are made after it's built, it can bring it down. So you don't want that. The allowed range of VLANs for the Ether channel should match that of the ports. You remember when we had our VLAN lecture that we had a command that would allow us to say, okay, these are the VLANs that can go over this trunk, these are the VLANs that can't. Well, if you change that for the ports, you must have the exact same setting for the Ether channel itself. You have to. You can't have the physical links denying some VLANs and having the logical bundling allowing the same VLANs. That's not going to work out too well. And then, VMPS is great. You're going to run into a lot of it out there in the field. That's the setup VLAN membership policy server that allows us to have ports dynamically receive their VLAN assignment in accordance with their MAC address of the host, but no port that is configured for a dynamic VLAN assignment can be part of an Ether channel. And think about it, that makes sense. And your Ether channel, your trunk ports by default are members of all VLANs. They're probably going to stay that way unless you go in with the accept command and take them out. So you definitely can't have an access port be part of an Ether channel, and you can't have a port that's getting a dynamic VLAN assignment be part of an Ether channel either. That simply would not work. A lot of details here to know for the exam then about Ether channels and what can bring them down and the protocols, all that kind of thing. The good thing for us in the real world is that once you've got an Ether channel up and running, it's going to run until somebody goes in and changes a setting. This is not something that goes up and down a whole lot or at all. And as troubleshooters, we always start at the physical level of the OSI model with troubleshooting. But the first question we always ask, especially when an end user is involved, the PC desktop, is what changed since the last time this was working? And the answer you always get, well, it was like that when I got here. We joke about that. End users can have that attitude, but we can't. If we are configuring a router or a switch, and maybe it can be accidental. Everyone makes mistakes. You can be meaning to configure your interface fast 011 and you put 012 in instead. You don't realize it, and you change the speed of a port, and all of a sudden you get all these messages. Port channel 0 is down, and you're thinking, oh man, what happened? Well, the odds are, if you're getting error messages like that at a console when you're entering commands, you did it. You'll do it in your career. I'll do it in mine. But again, we can't take that attitude of, well, I don't know why that happened. Most likely it's because of the commands you just entered. So again, these are important things to know for the exam. But if you change a speed or a duplex out there in the real world and you bring an Ether channel down, just take an extra look at what you just configured because you might have just selected the wrong port. This may be more detail than you want to know about how traffic is distributed over an ether channel. And right now, let me copy a line here. Now, this is something that we don't think about that often because, frankly, most of the time we don't care. It's good to know for the exam, and in rare instances you will need to do some looking up of information here yourself, but I'm going to tell you how to get started with it in a situation such as this, because spanning tree looks at an ether channel as what? One logical connection. We know that. It's going to look at it as one logical connection. You or I run a command show interface trunk, and we're not going to see three individual physical paths here. We're going to see PO1 for port channel 1, or whatever number we decide to give it. But we still have the physical paths in there, and the switch on the left here has to make a decision about how it's going to forward frames to the other switch in question when, say, A sends frames that are destined for B, or B sends frames to A. Now, the load is not going to be shared equally over all links in the ether channel. And obviously we're going to have a lot more hosts than this on our switches. But the key here is to keep in mind that the switch on the left is not going to say, okay, well, I've got 100 frames to send, so I'm going to send 33 of them over each line. It doesn't work that way. What happens is the switch is going to run the exclusive OR computation, or XOR. And it's a rather complicated binary operation where the switch will take a value, by default the source MAC address of the frame, run an XOR against it, and that will give the switch a value, and that value reflects which physical line here should be used to actually send data across the ether channel, whether that be line 0, 1, or 2 here. So it's interesting to note here then that when A sends data to B, it's always going to take the same physical path, because whatever computation we use, or whatever value we use for the computation, whether it's source MAC address or we change it to something else, then that's going to be constant, and the switch is always going to get the same answer. So again, in the real world, the vast majority of the time here, my friends, I really don't care about it. You're not going to think about it, and you're not going to notice it, and you probably won't care. The only time I would watch out for this is when, let's say that B is a very busy server or some other machine on the network that A has a lot of data to send to. In that case, we may want to work an XOR computation or some kind of load balancing scheme over the ether channel to get some of that data sent over different links. Maybe we don't want to overload one of these lines. If A is sending a lot of information to B, maybe we want it to take different paths or even try to load balance it. Now, the XOR computation, it's very difficult to find any documentation about this, even just having to do with Cisco. If you use Google or your favorite search engine, you're most likely going to come up with a lot of non-routing and switching sites, and that's fine if you ever feel the need to really dig in and do this. It does come in handy once in a while. And again, that would be if you have two particular hosts or one host sending another host data, and that's the majority of your traffic. But in most production networks, the data is pretty much spread evenly, and this is something you're not going to pay attention to. But I want you to keep this in mind for your exam and for the real world, that we're not talking load sharing here with an ether channel. There's not any kind of default load sharing. And by definition, when B sends data to A, it's always going to take the same physical path. And when A sends traffic to B, it's always going to take the same physical path. So that's how we distribute traffic over an ether channel, or how the switch does it actually. Quick command reference here for you, and as a CCNA and you're on your way to the CCNP, I know that you know these, but I'm putting them up here anyway. I just want you to review them. Don't fast forward through this, because there's an extra command in here I want to show you. And again, just the only reminder I would put up here for you is with your telnet lines, do not forget that on a Cisco switch, most likely you've got 16 lines and not 5. So instead of VTY04, we need to put 015. That is a big difference. You know about enable password and enable secret. You know how to use the command service password encryption. This is the command I didn't mention during the lecture, and I've configured this on the terminal lines, transport input SSH. This allows your switch to accept only secure shell connections. Now, this is by no means all you need to do to get your switch to accept secure shell. Trust me, there's a lot more to do, and that's really out of the scope of the exam, so unfortunately we can't cover it here. But unlike XOR, you're going to be able to find SSH Cisco-related documentation very easily at the website and just in a search engine. And with Telnet, we're assuming that your user is telnetting in on a non-secure connection. We are assuming that they have no encryption going on during the connection. And in today's world, that's just not a good idea. So again, secure shell, very minor topic on your exam, if at all. But take a few minutes one day, pull some Cisco documentation about secure shell and read it. Because if you're not running it now, there's a good chance you will be one day or perhaps at another job. And it's a good idea to know what secure shell is all about if you don't already. Showed you how to use the interface range command. That does come in handy once in a while. And error disable, these are the commands that allow a switch to recover by itself from an error disabled state on a port. So there's no manual intervention needed. They don't have to call you at 3 in the morning to telnet in and open a port up. Again, it's not always appropriate. Maybe with, say, port security, you want the port to stay shut. But occasionally, you may just want it to stay shut for a few minutes and then reopen. The error disable recovery cause command defines the cause or causes that we want the switch to auto recover from. Here I chose the word all. You can actually tie that down to several different features as well, port security, that kind of thing. Keep in mind again that with iOS help, it'll always show you the unit of time or data with any command. You should always look that up. This particular command I put up will have the port come out of error disabled state in 5 minutes. That's 300 seconds, not 300 minutes. Pretty important difference in time there. Just a reminder about the Ether channel commands, the channel protocol command, and then how to actually configure a port channel or an Ether channel with a channel group command. The options for that last command, active and passive, are the LACP options, desirable and auto, the PAGP options, and then on, we talked about that being the non-protocol related option. Active and desirable are doing the same thing, so are passive and auto. If both ports on the other, if the two endpoints or the two end ports are both configured for passive or auto here, we will not get a Ether channel over that particular trunk because they're both waiting for the other port to initiate it. You got to have at least one in active or desirable depending on which protocol you're running. Quick exam review here. And again, for many of you, this may have been or is second nature. And if that's true, fantastic. If it's not true and you're rusty, say on, how does the switch build that MAC table? How do we build an Ether channel? Please review this chapter before going on to the other videos, because this is the fundamental level. And there's no disgrace in not quite remembering something you studied. Maybe you got your CCNA 2 years ago and you don't quite remember how that MAC address table gets built. Maybe that's not part of your job. That's fine. There's no disgrace in that. If you learn something and you don't use it for a long time, it does get rusty, and let's face it, you forget it. So, but make sure that you review this video before moving on, because you can't build the intermediate and the advanced skills if you don't have the fundamentals. Having said that, quick Ethernet review here. Just a couple of bits there about Ethernet and fast Ethernet and gig Ethernet. It's never a bad idea for exams to know the IEEE numbers. That's just the way it is. Occasionally they like to throw that in kind of as a tiebreaker. And that's certainly no NDA violation. I think we all know that if we've ever sat in front of one. So it's never a bad idea to know your IEEE numbers. Never a bad idea to know your cable types either, rollover, straight through, and crossover. These are not the only uses for a straight through cable or a crossover cable, but they're the germane ones since we're talking about switches here. Again, know your basic switch operation, how that MAC address table gets built, the whole flooding, filtering behavior. Know your passwords and their effect. We just took a look at those commands a few minutes ago. Just a quick review here about Ether channels, about how it's a logical bundling of physical links. The XOR operation will actually decide which physical path in the Ether channel data will take. STP considers an Ether channel to be a single logical path. That's one reason we use it. And changing the VLAN port assignment to dynamic, changing the allowed VLAN range for either the Ether channel or a port, those should match. If you have ports that are configured to only allow VLANs 1 through 100, your Ether channel should be configured the same way, and so should all the other ports. Or my favorite, changing the speed or duplex of any port. These are just some of my favorite things that can bring an Ether channel crashing down. So good things to know for the exam and for the real world. And that's really about it. Like I said, for this particular video, like I said, if you're very comfortable with these, please go ahead and proceed to the next video. That's fantastic. If not, please take the time to go back and watch the video again, and a third time if you need it. Don't be in a hurry. The CCNP is going to be there for you, and you're going to get it. But the only way you get it is to master the fundamentals. And you have to be honest with yourself there. You know, do I really know this the way I should? If you do, proceed, and I'll see you on the next video. If you don't, watch the video again, review it, and I'll still see you on the next video. Welcome to Train Signal. I'm Chris Bryant, CCIE number 12933, and this is video 3, Switch Operation and Configuration. And there's a lot of different categories of information that are contained in this particular lecture. As you can see right off the bat, we're going to spend a few minutes talking about Ethernet. In just a few minutes, it's going to be a general review of some speeds and some things to watch out for. Also, for those of you who have not had the opportunity to work with gigabit Ethernet or 10 gigabit Ethernet, whoever thought there would be such a thing, this will be a good introductory lesson for you. We're going to talk about that for a few minutes and then talk about how a switch builds its MAC address table. And that's information you may recall from your CCNA. It'll be a good quick review. We'll see some of this in action. We're going to talk about some basic switch commands as far as configuring a host name, which you should know how to do as a CCNP candidate, putting an IP address on VLAN 1 and why we would do that, and the different switch passwords. So the first part of this may be just a review for you, but it never hurts to review this material, and you are responsible for it on your upcoming switching exam. Then we're going to talk about some helpful admin commands, just some commands here and there that will help you with your switch administration. And then after that, we're going to go into a very detailed look at Ether channels. Now, if you have no background with Ether channels or you're not quite sure what they are, don't worry about that, because we're going to start with the basics, because some CCNA curriculums have Ether channels and some don't. If you've studied with my materials, you know how to build an Ether channel. We're going to the next level with our Ether channel knowledge. We're going to talk about the protocols that actually assemble an Ether channel, so to speak. I'm going to give you some real-world examples of things to watch out for when you're configuring one and after you finish configuring one. It's going to be a good lecture. So let's get started then with just a quick overview of Ethernet. And of course, Ethernet is based on your IEEE 802.3 standards, offers a bandwidth of 10 megabits per second, and runs at half duplex, which means that a host running Ethernet can only send or transmit at any given time. It cannot do so simultaneously. And I know you are familiar from your intro studies and your CCNA studies about CSMA-CD, which is the collision detection mechanism in Ethernet. If you're not familiar with that, you might want to go out and do a quick check on the net for CSMA-CD and just review that. Wouldn't be a bad idea. You're not going to see it on your advanced switching exam, but if you're rusty with that topic, you should take a look at it. And when we're talking about collision domains, our switch ports serve as a collision domain with one host, as long as each host is connected directly to the switch. So one of the reasons we use switches is to avoid collisions. And if all of our host devices are connected to their own switch port, we literally cannot have any collisions. They are all in their own little collision domains. Ethernet uses UTP cabling, unshielded twisted pair. The cable limit, good thing to know, is 100 meters. And we're going to map this a bit to our Cisco 3-layer model that we keep coming back to, where we've got our core, then our distribution layer is outside of that, and then our access layer is outside of that. And when it comes to the 3-layer model in Ethernet, the only layer that you can really use Ethernet with is the access layer, where the users are actually being connected to the access layer switches. Because the transmission limitations of Ethernet, since it runs at half duplex, and it offers a bandwidth of 10 meg per second, but of course, since you're not sending and transmitting, sending and receiving at the same time, you're not really getting the full effect of that 10 meg. The limitations, the built-in limitations to Ethernet it's really not useful at the distribution and core layers. It could be used, but if you've got a campus network, once you get to your distribution and core layers, hopefully you've got lots of fast Ethernet. And fast Ethernet is defined in IEEE 802.3u if you want to read up on the technical side of it. Fast Ethernet operates at 100 meg per second and it runs at full duplex, which means that it can send and receive at the same time. That makes the effective throughput of fast Ethernet 200 meg. And you can still use UTP wiring, but you can also use fiber. Now, fiber is still expensive, but it can be used for fast Ethernet. And what you may have seen on some Cisco switches and other devices in the past are what are referred to as auto ports sometimes, but they're actually 10100 ports. And these are ports that can run at 10 meg for Ethernet or 100 meg if it's a fast Ethernet connection. And to allow the negotiation of this port speed, the end devices need to be configured for auto negotiation or simply auto. Fast Ethernet